Hey everybody, in this box I have the brand new Poseidon Triton road bike. In this video I'm going to show you how to build it. First thing you want to do is grab a pair of wire cutters and then carefully cut the seat posts free. You can set that aside. Then you can pull out the wheels, set those aside, and you can pull out the frame. Ooh, super light. At the bottom there's also a small parts box too, so make sure to grab that. You can go ahead and unwrap the saddle, and you can pull this little plug out of the seat tube in the frame. You want to spread a thin layer of grease on the inside of the seat tube of the frame to avoid binding on metal-to-metal surfaces. Next, slide the seat post in, leaving a few inches exposed, and cinch down the seat post collar with a 4mm Allen wrench. No need to tighten it down super tight right now. We're going to do a final fit at the very end. If you have a work stand, now's the time that you'd want to bring that out and hang your bike so that it's a little bit easier to work on. If you don't have a work stand, this step is completely optional, just makes it a little bit easier. At this point, we need to get all this foam and packaging off. Just be really careful when you're clipping zip ties not to chip the paint or otherwise scratch any part of the bike. Keep in mind that it's okay for the handlebars to hang from the cables, but do your best to try not to put any kinks into the cable housing. We can then get our handlebars mounted by removing the 4 faceplate screws using a 4mm Allen wrench. Oh look, I'm actually wearing the Poseidon shirt today. Random coincidence. Okay, now when we're installing handlebars, if you just put them on like this, how they came out of the box, you're gonna get these weird cable runs that are not how the manufacturer was intended. So what you wanna do is actually get the cables so that they're all below the handlebars and not awkwardly kinked in any way. There's generally only one cable routing from the factory. It might take a couple of tries to figure it out, but let's get this faceplate reinstalled and I'll show you the proper cable orientation. So you notice that the faceplate actually comes in 2 halves and they're asymmetrical. So there's a little bow in each of the faceplates. You want the bowed portion to face outward from the bike, and that'll offer the maximum amount of support for the handlebars. Now, interestingly, there are no markings on this particular handlebar that help you align the bar with respect to the stem. So all I'm doing here is using a ruler to take a couple of measurements. I'm measuring from the center of the bar end plug to the center of the stem mounting bolt on its respective side. So here I've got 27.5. Here I've got 27, which means I need to slide the bars over just a tad to the right. Now your reference point doesn't really matter as long as both sides measure the same. I've got 27.25. and 27.25. So now I know the bars are centered. I'll cinch them down here and we'll get the rotational adjustment dialed in just a little bit. So this is the proper cable orientation as shown from a couple of different angles here. Another thing you want to make sure of is to get the gap between the faceplate and the body of the stem. You want that gap to be equal on the top side and the bottom side as well. So next we'll get the drivetrain put together. Note that the derailleur comes detached from the bike. That's to hopefully prevent any damage to the hanger in the process of shipping. But it does mean that we have to install the derailleur onto the hanger. Now fortunately for me here, the chain came kind of aligned properly. It's not tangled up or anything like that. The cable routing is also on the correct side. It is possible that the chain will come wrapped up, and when you go to unravel it, it may get a little bit of a kink or a tangle in there. The key to detangling chains is to resist the urge to pull on anything really tightly and just very carefully try and detangle it link by link. At the factory, the bike was actually assembled and the chain was in the proper orientation, so there should be no reason that you have to actually take the chain apart and reinstall it. The other thing to note is that this cable coming out of the drive side chainstay should be feeding the derailleur on the outside of the derailleur. Now if this cable does actually happen to be routing on the inside of the frame through here, there's a quick video on Poseidon's website which will help you detangle that. It's really just a matter of rotating the entire derailleur and chain over so that the cables run in the proper orientation. It just might take you an extra minute to sort that out, but there is a video on Poseidon's website to help with that. Next we're going to install the rear derailleur, and that's going to require a 5mm Allen wrench into this bolt hole here on the derailleur, which turns these threads on the inner side of the derailleur here. And we need to thread those into the derailleur hanger, which is down here. It's definitely not this one. That's where the axle is going to mount. The hanger is slightly below and behind the dropout here. Now keep in mind too that there's this little tab on the inside of the derailleur, and so in order for the threads to fully engage, the derailleur actually needs to be rotated far enough such that tab clears the little tab on the derailleur hanger. And this is what the derailleur should look like when properly installed. Okay, so if we unpack the small parts box, first thing that you notice is actually it comes with the tools that you need to build this bike, which I actually wasn't aware of till just now. You've got a 3-4-5 Allen wrench, little Y tool right here, and here you've got a 6mm Allen wrench. It also actually comes with a little bit of grease. So if you don't have your own and you don't want to buy an entire tube, you actually have enough here to build the entire bike. Then of course you have reflectors that come with the bike. There's 2 for the wheels and 1 for the front and rear of the bike. You also get a pair of relatively cheap plastic test ride pedals just to get going with. your front and rear through axles to hold your wheels to the bike. Your disc brake rotors are packaged nicely inside of this foam. It also includes your disc rotor lock rings. This bike uses a center lock disc rotor mounting system as opposed to the more traditional 6-bolt, which is very nice. And then lastly, this is actually a huge surprise. There is a bottom bracket tool in here, actually. Now this is really cool. I've never seen this included in a bike kit before. So this should be good for a lot of standard bottom brackets, but the reason they included this is actually this is how you're going to lock the disc rotors onto the wheels themselves. So really cool that they included that. And that's everything that comes in the small parts box. At this point, you can unpackage the wheels. There are these little end caps that come off the hubs here. There's a plastic piece that's capped to a metal end cap. And you want to separate those because this piece right here is trash, but this is totally not trash. This is a critical part of your wheel. If that does pop out like it did in my case, what you want to do is just slide it back in, and all that takes is a little pressure and it's slid into place. For the rear wheel, there's a little bit of extra packaging because you've got the cassette. So we want to unclip this zip tie, remove that, and that'll expose your microshift cassette. There's also a plastic packaging piece on the non-drive side. Now at this point, we can actually install the disc rotors. A really easy way to work on your wheels is actually to just take the small parts box and kind of allow this center part to kind of depress. That will hold your wheel nice and steady while you work on the wheel. On the wheel, you will notice a splined side of the hub. That's the side that the disc rotor is going to attach to. So when you're opening the disc rotor package, I'm going to just be really careful not to touch any of the braking surfaces with your bare hands. The reason for that, of course, is that even if your hands are clean, you've still got natural oils. Once those get on the brake rotors, it's possible that they will contaminate the brake pads, after which point there's really not much you can do except to replace the brake pads, which you don't want to do. Okay, so you've got two rotors. They are not front rear specific. You can use either one on either wheel. Now before you install the rotors, you want to put a thin layer of grease on the splines on the hub mounting surface for the center lock rotor. Again, holding the disc rotor not from the edge or the braking surface, you're just going to slide them onto the hub, like so. Rotationally, it doesn't matter where you put them. What does matter is that you put it on the correct orientation. You will see that there is a flat side on the top and then a side with the mounting surface just below the rotor. This is the part that's going to mount onto the disc hub here. So it's going to look like this. In order to secure it, you're going to open up one of the disc rotor lock rings. And for me, it's just a habit to do this. You don't have to do this. I like to put a thin layer of grease on the threads for the rotor lock ring as well. And then you're going to thread that into the threads on the inside of the hub. Now, these are very fine threads, so you want to make sure not to cross thread them. It should basically spin freely up until you hit resistance when the lock ring is touching the rotor. At this point, what I like to do is actually put the wheel on the ground. The length of this tool is such that you can basically turn this as hard as you can, and that's going to be about the right torque. Just for good measure, supporting the tool, holding it in place so it doesn't slip, and then just pulling until I basically can't pull anymore. And that's going to be one rotor done. We just need to repeat the same thing for the other side. All right, so next you want to find both the through axles that came in the small parts box, and then just give the threads just a light layer of grease as well. You're going to have two axles. The short one is for the front wheel. The longer one is for the rear wheel. The trick here is that two things have to happen simultaneously. You need to get the chain around one of the cogs on the cassette, preferably the smallest, and at the same time you need to make sure that the disc rotor slides between the two disc pads on the caliper. Grab the derailleur. You can just force that down to give yourself some slack while you bring the wheel up and align the chain to the small cog, like so, and continue to roll the wheel up until you can get the disc rotor between the two pads on the disc caliper, like so. Continue to apply upward pressure so that the wheel doesn't fall out, and then you can go ahead and insert the through axle from the non-drive side through the drive side until the threads catch, and you can crank the through axle down. This is where a little bit more grease, even on the shaft of the through axle, may have helped out with that squeaky noise a little bit. Once you have that cinched down, you want to aim for roughly 12 Newton meters of torque on the through axle, which is, fairly tight, but don't overdo it. Don't go crazy with it. Now, of course, this is a 6mm Allen wrench to cinch that down. The front wheel is even easier than the rear, because we don't have to contend with the chain and the cassette. I am actually going to put a light layer of grease on the shaft of the through axle itself, just to avoid any of that kind of squeaking as we install it. I'll probably take out the rear wheel and do the same. I recommend you do the same as well. Front wheel, pretty straightforward. You can feed the through axle through. Sometimes it takes a little bit of jiggling for everything to line up. and then you can crank that down again, 10 to 12 Newton meters. Now, one thing that I did know is that if you look at the drive side of the front fork, the through axle actually protrudes quite a bit, and that's a little bit uncommon. So Poseidon have actually included a spacer that looks like this. It's just a little through axle spacer that you can place on the non-drive side or the head of the through axle. So I'll do that now to show you what that looks like. Basically, you'll just slide that spacer right onto the front axle like so, which gives you a little bit of a spacer there. That way, when you reinstall the wheel, you should, in theory, have a little bit less protrusion on the drive side of the through axle. So that's looking a lot better now. Okay, so it's actually starting to look like a bike at this point. We're gonna go ahead and get the pedals installed next. The thing about the pedals is that these are left-right specific. So you notice on the plastic pedal itself, there's one that's denoted R for right, another is denoted L for left. Even if those stickers aren't there, generally speaking, there's some marking. So on the spindle there, that says R. On the spindle there, that says L. And even if those letters aren't there, it's actually pretty traditional for the drive side pedal to have no knurling on the little spindle part right there. And the non-drive side pedal will actually have these knurls there. That's typically how you would identify left and right pedals in the past. The reason this is important is because the pedals are thread specific, meaning that the drive side pedal, where the chain side is a standard thread, which means righty-tighty, whereas the left side crank or the non-drive side crank is reverse thread. It can be a little bit confusing, but before we actually install anything, we definitely want to make sure to grease the threads on the pedal. So you can either apply grease to the threads of the pedals directly, or you can apply grease to the inner threads on the cranks. Okay, so just to be absolutely certain here, this is the pedal denoted R for right, and this is the drive side crank. I'm going to insert and turn righty-tighty like I would normally screw in any other threaded fastener. Okay, so this should thread in really easily with basically no resistance. And of course, if you turn the pedal, actually nothing's going to happen because the pedal can spin with respect to the spindle, but sometimes there's enough friction just to get it going. I've got the spindle all the way tightened up to the crank arm at this point, and that's what it should look like. We'll tighten these down in just a second, but we just want to get them cinched up like this first. This is the left side crank, the non-drive side crank. This is the pedal marked with an L on it for left. We're going to take the threads and we're basically going to unscrew them as you normally would. So it's a reverse thread, lefty-tighty, which is kind of weird to say, but you can see that as I am turning the spindle counterclockwise when looking head on, the threads are actually engaging, and I'm cinching this pedal down. Now, when you're tightening pedals, if all you have is like a crescent wrench or an adjustable wrench like this, that will work. Sometimes, though, it's a little bit tricky because you need a thin enough wrench to get between the body of the pedal and the crank arm itself. So in this case, an adjustable crescent wrench will work. Sometimes you run into the risk of scratching your crank arm if the wrench itself is too wide. So in this case, I much prefer to use a dedicated pedal wrench that looks like this. It's 15 millimeters, which is meant for pedals, and it's also really thin. So it'll fit nicely between the pedal and the crank arm without touching it. Now, one trick for tightening down pedals is just due to the orientation of the threads, you can actually hold the rear wheel, and that's going to hold the crank in place from spinning. You just hold the wheel and then crank down. Again, this is the left side, so it's lefty-tighty. You don't need a ton of torque on these, just enough to make sure that the pedal's not going to fall out. The right side will go the same. Hold the wheel, and that gives me the leverage I need to tighten the right pedal down to spec. We're going to be spinning the tires a lot, spinning the wheels, braking, adjusting gears in just a minute. Sometimes without any air in the tires, the valve can actually shift if there's no tension on it. So it's actually a good time to inflate the tires just to make sure that they're not going to spin with respect to the rim as we start doing the final adjustments. Just make sure to adhere to the manufacturer's specification for whatever tire you're inflating. And if you're not used to using this type of valve, this is called a Presta valve, aka a French valve. It's different from a Schrader valve, which is what you'll typically see on a car. What you want to do is remove the valve cap. This is just a dust cover. It really does nothing to hold air in. But there's also the inner valve that you have to unthread so that you can get air in. So you can just unthread this all the way. It's not going to fall out. There's like a hard stop at the end. And then you need a Presta compatible pump head to be able to inflate this tire. If you only have a pump that's good for standard Schrader valves, you can buy cheap, $2 adapters that will allow you to use a standard pump on the Presta valve. Then when you're done, you want to tighten down that valve until it stops. This is sort of what locks that valve into place. Make sure that this little lock ring on the valve stem is tightened down as well, otherwise you get some rattling. You don't want to be hearing that sound while you're riding. So make sure to tighten that down, snug up against the rim so that everything's nice and solid. Then if you'd like, you can replace the dust cap as well. Okay, so it really doesn't matter which we address first, brakes or shifting. I personally like to do brakes first because while we adjust the gears, we are going to need to rotate the back wheel. And so if the brakes are rubbing, then it's just a little bit annoying. So I like to knock the brakes out first. What's really helpful is to actually shine a light behind the disc caliper. You'd like to see a gap on either side of the rotor between the rotor and the pad. And in this case, we're seeing a gap on the inner side, but we're not seeing a gap on the outer side. So that means that the caliper actually needs to be slid outboard just a hair to produce that gap so that there's no rubbing of the disc rotor. See if you can hear this rubbing. That is what we want to eliminate. And the way we'll do that is to take a 4mm Allen wrench and just loosen up the mounting bolts behind the caliper here, just enough so that the caliper can slide laterally. And the goal here is to keep the pads parallel to the surface of the rotor, but align them such that you've got an equal gap on either side. This part may take a couple of tries to get right, but when it's properly aligned, you'll see a gap on either side of the rotor, and you won't hear any of the rubbing anymore. So now, let's see if I can capture this here. We've got a gap on either side of the rotor, and we're not hearing the disc brake rotor rub on the pads anymore. The rear brake is the exact same process. In this case, I've got to bring the caliper just a touch outboard. And again, having that light just behind the rotor makes it really easy to see if and when you have any rubbing. All right, so the brakes are done. Now, the last thing we're going to tackle is, of course, the drivetrain. The Triton ships with Microshift's Sword 2x drivetrain, which is really cool. Super high value per dollar, in my opinion. This group set is really nice, fully mechanical, but just works really well for the price. The right-hand shifter is going to control the rear derailleur. You're going to push the big paddle, the lower paddle, which is the larger one, until it clicks, and that's going to move the chain up the cassette, which makes it easier to pedal for climbing up hills. You're just not going to go as fast. Then, of course, the smaller paddle on the right-hand shifter will bring the chain down into a smaller cog, which is going to allow you to go a lot faster with a slower cadence. Same is true for the front derailleur. You've got two paddles on the left shifter. The bigger paddle is going to take you from the small chainring up front to the large chainring. And the smaller paddle is going to bring you back down from the large chainring to the small chainring. Now, from the factory, the drivetrain should be decently set up, although you might have to make some small adjustments. If you notice here, as I pedal, just some unwanted kind of grinding and mechanical frictional noises. So in this case, we do need to make some adjustments. Now, if you've never adjusted a drivetrain before, it's not as complicated as some make it out to be. Derailleurs are nothing more than spring-loaded actuators that push the chain laterally from side to side. As I push the big paddle on the right-hand shifter, you'll notice that the derailleur gets pushed downward away to clear the larger cogs, but it also gets pushed inward. So the first thing that we want to do here is to what's called index the drivetrain. That just means that for each corresponding click of the shifter up here, the chain is exactly lined up with one of the cogs on the rear cassette. Now, to index the rear derailleur, what you want to do is to click the big paddle on the right shifter so that the chain is in the second to smallest cog. Now, the reason we use the second to smallest cog and not the smallest or the largest is because the indexing process is meant to align the chain with its proper cog along the cassette, but there were two additional adjustments that we can make called the high and the low limit screws that if you try to index with respect to the smallest or largest cog, you can kind of mess up the indexing if the high and low limit screws are not properly adjusted. So in order to eliminate that variable, just put the chain on the second to smallest cog. So the upper pulley wheel is right here, and you want that to be in the same plane as the second cog on the cassette right here. Now, if you find it in a position that's maybe too far inboard, like this, in that case you may start to hear some ticking or otherwise unwanted mechanical noises like this. Okay, so that's definitely not what you want to hear. I've artificially pushed the upper pulley wheel too far inboard by using what's called this barrel adjuster. Now this is a threaded little piece on the derailleur itself that allows you to make micro adjustments to the lateral position of the derailleur. So if you screw this inward, it's going to allow the derailleur cage to move slightly outboard. If you screw it outward, as if to unscrew this thing, you're going to effectively put more tension into the system, thereby pushing the derailleur inboard. As I bring this barrel adjuster in, just a quarter turn at a time and see what happens. What I'm doing is I'm pulling the derailleur further outboard to align it with that second cog. At some point you'll hear that ticking sound go away. And so now we're aligned. And because the indexing of the shifter is matched to the indexing of the derailleur, once I've aligned the second cog, everything but the highest and lowest cog should now actually be indexed. Okay, so we're looking pretty good at this point. Now what you want to do is actually go ahead and try and shift into the largest cog and the smallest cog on the cassette, and we'll just observe what happens. Okay, so I've gone into the largest cassette, which is my lowest climbing gear, and if you notice, the upper pulley wheel is not quite aligned with that cassette. It's a little bit too far outboard, and it needs to go inboard just a tad. That's where the high and the low limit screws come into play. These are basically hard stops on how far the derailleur can go laterally. Sometimes they're set up a little bit too conservatively, which is why we'll need to adjust, in this case, the low limit screw. Now keep in mind that the L on the derailleur stands for low limit screw. That corresponds to the largest cog on the cassette because that corresponds to your lowest gear combination. And correspondingly, the high limit screw will control the upper hard stop for when the chain is in the smallest or highest gear up here. Now this is actually going to require a 3mm Allen wrench. And what I'm going to go ahead and do is put the 3mm into the low limit screw, and I'm going to back it out by about half a turn for starters. And I'm not sure if you can see that, but going even just half a turn, you can see the derailleur cage being pushed inboard just slightly because I'm relaxing the upper limit on that hard stop. So now, shifting back and forth between the second to largest and the largest cog, I no longer have any issues getting into that big cog. And what you want to be careful of is not to relax this screw too much, because that'll create the possibility of the chain going too far and actually going over the largest cog and sort of getting stuck in your spokes, which you don't want. Same is true for the high limit screw. So let's bring it back down to here. So I'm now at the second to smallest cog on the cassette. I'm going to attempt to put it into the smallest cog, and we'll see what happens. So there's a bit of hesitation before it goes down. So if you notice, I'm in the second cog again here. As I click the shifter, there's a little bit of hesitation before it wants to come down into the smallest cog. To me, that indicates that the high limit screw is a bit aggressive right now. So I want to relax that, putting the 3mm Allen wrench into the H screw on the derailleur. I'm going to back that out about a quarter. I think this one's only going to take about a quarter turn, but you can actually see visually that the cage is moving laterally as you turn the high and low limit screws. So I backed it out about a quarter of a turn, go back into the second cog, and let's see if it shifts into the smallest cog easily now. Yeah, perfect. So I have no issues going from the first to the second cog now. So my high limit screw is set. I've indexed the rest of the cassette already, and I've set my low limit screw already, so I should be able to go through the entire cassette at this point, and we are good. So I'm going to leave this in the smallest cog on the cassette, and we're going to go ahead and adjust the front derailleur at this point. The concept is exactly the same. As you pull more tension into the system, the derailleur pulls outboard, which is actually opposite from the rear derailleur, and it moves the chain from the smaller chain ring to the big ring. As you relieve tension in the system, the spring-loaded derailleur will drop the chain from the larger ring back down to the smallest. Just give it a pedal. When you're in the small chainring on the front and the small cog on the cassette, you want basically minimal rubbing of the chain on the outer plate of the derailleur cage. Now this is called the small gear combination. It's really not a combination you ever want to find yourself in. So adjusting to where you're just barely rubbing at this point is a good starting point. So I've actually got just a tiny bit of rub, like at a couple of times through the pedal stroke. So the position at this checkpoint is actually pretty good. I'm going to go ahead and shift the rear derailleur into the largest cog. And I'm going to see if I get any rubbing on the inner plate of the front derailleur. And I actually do. You can hear that. That's the sound of the chain rubbing on the inner plate of the front derailleur, which means at this point in time, the derailleur is too far outboard, and I need to push it inboard just a little bit to relieve that rubbing. To do this, we've got the same concept as the rear. We've got the high and the low limit screws. In this case, I need to take the low limit screw and just back it out a little bit. Okay, so just to give you a wider shot here, I've got a lot of rubbing now between the chain and the inner plate of the front derailleur. I'm going to go ahead and bring the low limit screw out until that rubbing just is eliminated. At this point, I've set the low limit so that the front derailleur is inboard enough to eliminate that rubbing. And then what I'm going to do, I'm going to go ahead and move the chain from the largest cog down to the smallest cog again. Now again, I'm going to probably get a little bit of rubbing at the outer plate of the derailleur. That's kind of normal. There's not a ton you can do about that. You can mess around with rotating the derailleur slightly to eliminate that, but again, small gear combination is not really a combination that you want to find yourself in too much. I'm going to go ahead and put the chain in the small cog and shift from the small chain ring up to the big chain ring by pushing the big lever on the front shifter. Now at this point, what I'm looking for is any rubbing between the outer plate of the chain and the inside of the outer plate of the derailleur. So you can see here, I've got basically no rubbing. So that's what I'm looking for. In my case, I actually have quite a large gap. So I might actually consider using the high limit screw to bring the derailleur cage slightly inboard until I'm just starting to hear some rubbing between the chain and the outer plate of the cage. And then I'll back it off just by like a quarter or a half a turn, just to get that spacing exactly where I want it, like so. So now I should be able to shift through the entire drivetrain. When I'm in the big chain ring, and I start to approach the big chain ring and the big cog on the rear cassette, this is called the big gear combination. This is also something that you want to avoid. Both small and big are referred to as cross chaining. It's generally pretty bad for your drivetrain. You lose a lot of efficiency and you wear your stuff out a lot faster. So we're going to eliminate that. But we're just checking to see if I can shift through the entire drivetrain. Okay, so I've gone all the way up and all the way down the cassette while I'm in the big chain ring. Then we're going to drop the chain ring and go all the way up the cassette. And then go all the way down the cassette. Now again, after I hit the smallest two cogs, I'm going to start to get a tiny bit of rubbing here. Again, these are gear combinations that you should generally avoid anyways. Now at this point, once you've adjusted the low and the high limit screws, if you're finding that you're still getting some rubbing of the chain with the cage of the front derailleur when you're in the big ring, that could mean that the overall amount of tension in the system is insufficient, and you might have to actually loosen this screw here, pull just a tiny bit more cable out, and then retighten it down, and that will adjust the overall tension, which is similar to indexing of the rear derailleur. We just don't have a convenient barrel adjuster to do it here on the front derailleur. But in our case here, the tension is set up properly, and so we've set tension in the rear, tension in the front, high and low limit screws for the front and the rear. This drivetrain is ready to go. Now is when you want to set up your fit and get all of the bolts torqued down to spec. So as a general starting point, when you're on the saddle and your foot is in pedaling position, you want a slight bend in your knee, somewhere between 20 and 30 degrees for starters. My seat right now is far too high because my leg is completely straight and I still got to kind of point my toe to get to the pedal. So I'm going to drop the seat just a little bit. This is probably about where I would have it. Got a slight bend in the knee when I'm fully extended there. Seat feels comfortable. Another thing you want to check out is the level of the seat as well. Some riders will have a preference to nose down or nose up, but as a starting point, you want your saddle flat. If you want to make these adjustments, it's two 5mm Allen wrenches on the bottom side of the seat post. Just loosen those up. You can angle the seat as well as slide the seat forward and backward. Generally speaking, a good starting point is just halfway along the rails, the seat rails. And then, fit is a very personal thing, so ride it for a while in that position. If you feel like you want to slide forward or backward, you can tweak it, in 5mm increments at a time. So the handlebar adjustment, this is also pretty personal. Generally speaking, you want the tops of the handlebar, so where it bends to go towards the hoods, you generally want to start with that roughly parallel to the ground. Okay, then keep in mind that the shifters, the brifters, sometimes they're called brifters because it's a brake and a shifter in one. The brifters can also be adjusted. So these are just band clamps that clamp around the handlebar. So the brifters can go up the bend, down the bend, and they can rotate in and out. It's a 5mm Allen wrench to make that adjustment. Take your time with these adjustments, kind of see what feels good. I'm going to leave them in this position just for starters here. And now the stem is the last thing we'll need to adjust. There are two stem pinch bolts on either side of the stem. They both use 4mm Allen wrenches, so I'm going to loosen. And as soon as I loosen that, I can now turn the bars with respect to the front tire. So I want to make sure that my handlebars are perpendicular to the tire. Now this you can just eyeball. You can use reference points with the edges of the forks to the surfaces of the handlebars. There are even tools that you can buy that will get this alignment, perfectly. And once you're comfortable with where they're at, don't tighten these down yet, because now is also a time when you want to adjust the headset as well. The headset is the set of upper and lower bearings that go in the head tube, and they're what allow the handlebars to turn without any friction. So the way to adjust the headset is to grab the front brake, which is in your left hand, and then put your finger over the headset bearing at the top and kind of rock back and forth. If there's any play between the fork steer tube and the head tube of the frame, that means your headset is too loose, and you want to go ahead and tighten down this top bolt here, which is a 5mm Allen wrench. This is called the preload screw, which allows you to compress the bearings in the head tube or relax them a little bit. So you want the preload set just tight enough where there's no play in the headset whatsoever, but not so tight that the handlebars don't freely rotate. So right now I've got the handlebars pretty freely rotating. There's no play in the headset as I grab the front brake and try and create any motion between the steer tube and the frame of the bike. At this point, I've got the preload set, my handlebars are straight. Now I can go ahead and re-tighten the stem pinch bolts, which are the two 4mm bolts on either side of the stem. Now, once you've got everything cinched down where you like it, the last step is to make sure all the bolts are tightened to spec, meaning they need to be tightened to a specific torque specification. And really the only way to achieve proper torque specification is by using a torque wrench, like this Feedback Sports one that I've got here. Any torque wrench that reads on a Newton meter scale from about 2 to 12 Newton meters will do here. Okay, so the places that need torque specs are the stem pinch bolts, the stem faceplate bolts, as well as the seat binder bolt here. The stem pinch bolts and the faceplate bolts will both take 6 Newton meters. Same thing for the stem pinch bolts here. So the seat binder is actually going to require 7 Newton meters of torque, according to the seat post collar. This is also a 4mm Allen wrench. Just tighten that until it clicks. Drop my torque spec on the wrench back down to its lowest setting, and we are done. So the last thing that's left is to actually do a process called bedding the brakes. Now when you first set up a brand new bike with brand new disc brakes, what you need to do is bed the brakes, which means ride it a little bit, engage the brakes slightly so that you deposit a little bit of the brake pad material onto the rotor so that they just mesh nicely. The way to do this is to just go out to an open place, like a quiet street, get up to about 10-15 miles an hour, moderate speed, and then drag one brake at a time, so start with the rear, drag the brake with moderate force until you come to a walking pace, and then let go of the brake so you continue roll. You want to repeat this process 5, 10, 20 times, whatever you're comfortable with, until the brake starts grabbing a little bit stronger. The key here is to not grab a ton of brake and not grab the brake until you come to a skidding halt. Repeat the same process for the other brake, and then you'll be ready to ride. Okay, so there you have it. Your Poseidon Triton is all ready to go. Now, I'm personally pretty excited to get some miles on this thing and kind of mess around with it. I'll have an actual review for this bike up pretty soon. In the meantime, I hope you enjoyed the video. Hopefully this video was easy enough to follow and you've got your Triton built up and ready to go as well. If I missed anything or if you have any questions about this particular build, just drop them down in the comments. I'll do my best to answer as many questions as I can. Thanks again for watching. Thanks for subscribing to the channel if you haven't already. We'll see you next time.